Review the steps that we have talked about in order to make a solution. You'll see that you need to measure out the water and the mass of your substance in grams. Well, to do that, you need to first figure out how many grams you need. In this problem, you're given that you are measuring 100 milliliters of water to make a 0.5 molar solution of iron 3 hydroxide. So that means you need to figure out how many grams of iron 3 hydroxide you need. So to do that, this is going to be first a mole problem and then mole converted into gram problem. So M is equal to mole over liter. So we know that we have 0.5 molar. And we know that we have moles as our unknown because we have to get moles into grams. And so then that leaves us with our volume. Now volume has to be in liters, so that's my first conversion. I need to make sure that this is in the proper unit. And then I'm going to divide. When I divide, I'm going to get that this is 0.1 liter. So that's going to go here. Now I'm going to solve for x. So x is going to be multiplying these two things. So x is equal to 0.5 times 0.1. And that's just figured out by kind of rearranging it through algebra to get x by itself. I need to multiply both sides by 0.1. So 0.5 times 0.1 is going to be 0.05 moles. So after I know that, then I need to go ahead and figure out my formula for my solid. So the formula is iron 3 hydroxide. So iron is Fe, and then the 3 means it has a plus 3. Hydroxide is OH, that has a -1. So this formula is going to be Fe parenthesis OH parenthesis 3. So I need to figure that out. So iron, if I look on my periodic table, is 55.85. Oxygen is 16, but distribute, which means that there's going to be 3 of them. And then H is 1.01 times 3 also, because we need to distribute. So add it all up, and you'll get a molar mass of 106.88 grams per mole. So you can use that and this information to figure out how many grams you need to measure out. So I'm going to kind of do that over on this side here. So if I have 0.05 moles, I'm going to do 1 mole on the bottom, and I'm going to take that times my number, 106.8 grams, and I'm going to get that I need to measure out 5.344 grams. Now I'm going to get that to a 10th place for measuring in my grams, so I'm going to say 5.3. For part 2, the only information you really need from the problem above is the molarity. Because this is the solution molarity you've made, and you're going to take some part of that to dilute. So remember, our dilution equation is going to be the molarity of the first one, which will be this, always from part 1. And then whatever volume I need, which is pretty much always going to be what we're solving for in these, is equal to whatever my new molarity I want to make in, and the volume of it I want to make. So my M1 is, as I said, from part 1, so that's 0.5 molar. And my V1 is what I'm trying to figure out. My M2 is whatever the new molarity I want to make is, so in this case 0.1. Sorry, I meant to do parentheses there. And then how much total volume I want, which is 50 milliliters. So now I want to multiply. 0.1 times 50, that gets me 5. And then this is going to be 0.5 V. So I'm going to divide both sides by 0.5. And I'll get that the volume of the first solution I need is 10 milliliters. So these are 2 important numbers that we're going to need when we actually go ahead and make our solution. First part of making the solution is to ensure that you have grabbed the right salt, and then you're going to measure out the part that you determine you need to. So make sure your label iron 3 hydroxide is what you're measuring, and then you're going to go over to your scale. You want to turn it on, then make sure it's zeroed. And then slowly start adding until you get to 5.3. And just go to the 10th because the scales are a little finicky. So I need to take a little bit out of there. Okay. So it's okay if your 100th is a little off as long as you're rounding to 5.3. Then you'll move on to the next part. The next part that you'll want to do is add your grams into an Erlenmeyer or a beaker. Then you need to measure some water. Now the water you want to measure, you want to make sure that we don't go over the amount that we're looking for. We're trying to make a 100 milliliter solution. Well, if I fill it up with 100 milliliters right away and then put it in here, the salt is going to take up some of the room. So I need to make sure that I do a little less. So I would say about 75, but somewhere between 50 and 75% of your water. So I'm just going to fill it up with about 75 milliliters to start, and then I'll go on to my next part. Okay, in this part, it doesn't really matter how precise you are. You're just trying to get some water to mix and dissolve your solid. It won't be till the end where you really need to be concerned about the meniscus. So right now, I'm just going to take this water that I filled up from the sink, and I'm going to pour it in there. And then I just want to swirl and always check the bottom to see if it is dissolved. So once it is all dissolved, then you're going to pour it back into your graduated cylinder. And notice my volume went up a little from what I had it before. And now I'm going to top off the rest with water. And you can kind of fill it. I know I want to get it to 100, so I don't necessarily need to go drop by drop. If I get up to like 95, then I can start being more careful of where I'm trying to put it. Okay, once I'm at this point, I want to get eye level. And then I'm just going to slowly kind of add water drop by drop until I get up to about 100. And as you get closer, you want to add it more slowly. Okay, so now you really want to be paying attention for the meniscus because I will be checking your meniscus, and you need to be at eye level to make sure that that is going to be at the right level. So that would be the meniscus at 100. And that's what I'll be looking for to make sure that your volume is correct. All right, now that my solution is done, I'm going to pour it back into my beaker. Or flask. And then I'm going to take a piece of tape and I want to label it. I'm going to label it as 0.5 molar and then FeOH3. Okay, now that's the end of part 1. I've made my solution and now I need to dilute it. So if we think about our dilution number, we got 10 milliliters. That means I need 10 of the solution I just made to go into a graduated cylinder. So I'm going to get ready to do that. Okay, just like before, we can kind of gradually pour up until we get somewhat close to 10. But then we're going to need to get to eye level to make sure we get right at the meniscus of 10. So we're going to take our solution here with the pipette and gradually go to the meniscus of 10. So that's all I want of my original solution, that 10 that I calculated. But I want the total volume to be 50. So from here all the way up to 50, I need to fill with water. And I need to be careful of my meniscus for my water as well. So I'm going to take some water and fill up till I get about close to 50 to dilute it. Once I get pretty close, I'm going to finish it just like I did the other one by adding water dropwise up to my meniscus. I want to make sure that that looks good. So I need a little bit more here. You can also use a pipette for this. You don't need to use the squeeze bottles necessarily. So that would be my meniscus. That would be 50. Pour it into my other flask. And I'll need a piece of tape and a label on that as well. So your label for this one should be 0.1 molar FeOH3. And obviously it is a lot more dilute. Does not look nearly as green as the original one. And that is how you will go through your solution making process.